Hello, everybody, and welcome back to the Azure podcast. Today is March 3rd, and we are recording episode 414, and we'll be talking about Azure DNS with Abhishek Tiwari here. So before we get to our special guest, Abhishek, Russell, let's talk about some of the news. There's some neat things out this week.
Yeah, I picked up on a few things. There were quite a lot of smallish announcements, actually. One of them was the general availability of Arrow, so Azure Red Hat OpenShift support for version 4.9, which some people might be interested in. I know OpenShift is kind of, I don't hear a great deal about it, but when I do, there's quite a lot of importance attached to it and a bit of focus for a period of time. So yeah, it's one of those things that sits out there that
I think if you use it, you're super dependent, like you are super passionate about it, and it meets some really targeted business needs for you, but it's not something everybody uses necessarily.
Yeah, okay. That was one. The next one was a feature within Azure Data Studio. So it's a new extension that's been written to help with migration, and it will go off and monitor an existing SQL workload and figure out what the SKU should be when you go and migrate it into the cloud. So I thought that was quite neat and quite simple.
Hey, Russell, did you catch on that? So I saw that, and I was assuming it would just sort of look at your database size and tell you some recommendations. Does it actually look at your running workloads and make some recommendations based on that?
That's what it says in the bit that I read.
Interesting.
I'll put
That's
the link
cool.
on the show notes, and you can have a look at that.
Okay.
The last one I wanted to point out was Azure Spring Cloud Enterprise. So again, a set of more updates around this service. So this is us working collaboratively with VMware, using kind of Azure Cloud features and our expertise of that public cloud platform with their Tanzu portfolio. And this preview contains features for deploying Spring apps, more platform managed features, so stuff that is automated for you. So some of the services like Tanzu Build, Spring Cloud Gateway, and API portal for Tanzu, all things you can pretty much checkbox deploy now and have managed for you as part of that service. And better integration with some of the other Azure automation things, so features that you would normally expect to see in Azure through automated deployment, monitoring, and integration. And some integrations with third-party services like Elastic, New Relic, Dynatrace, and App Dynamics. So I thought that was pretty good. A good set of sort of third-party tools and integrations there.
Yeah, great. No, so the two that I wanted to call out today, one was sort of, and I like the WordPress on app service. It's almost WordPress as a service. When I was looking at it, we basically, launched sort of a new variant of, or I guess some enhancements to the WordPress support in app service, where they, as part of the deployment, you get some configuration that comes along for the ride. So you're not sort of deploying this bare, WordPress thing, then you have to go configure it from there. Some performance enhancements, just sort of making WordPress run better in app services. And then the other one is the application consistent snapshot tool, AZAC-Snap. So somebody I think had to work to find that name. But this is something that allows you to take application consistent snapshots, and this is across Oracle. It's for SAP HANA scenarios, it works on top of NetApp files, bare metal, and as well as managed disks. So again, if you're living in that SAP HANA world, again, something else to check out in terms of doing your backups. But yeah, so that's a good list to start. At this point, let's take this over to Abhishek. Abhishek, if you could, tell us who you are and what you do here for Microsoft.
Sure. Thank you. Thank you for inviting me in this podcast. I really appreciate it. I'm Abhishek Tiwari. I manage the Azure DNS and Azure Front Door suite of services. The Azure DNS is responsible not just to have a DNS service provided to Azure customer, but it also provides, it's a platform for Azure infra and almost entire Microsoft. All the crown jewels of Microsoft runs on the Azure DNS. On Azure Front Door sites, it's offers the application acceleration, CDN, content caching, WAF, and then other sort of protections offered from the edge of Microsoft.
Yeah, we'll save the front door stuff for later, because I think we're going to have you back, a little bit down the road to talk about front door, because it deserves its own. It's big enough to deserve its own thing. So we'll focus on DNS today. I mean, Azure DNS. I mean, it's to your point, right? Everything in Microsoft sits on top of it. There's sort of the the internal infrastructure, variants that we have. There's the private DNS that customers use, and there's the public DNS. Like, is this all one big service? Is it different pieces? Like,
Yeah.
how do we manage that?
Yeah, true. When we say DNS, most thinks it's a one big DNS service that's serving all these things, and that's not the case. Under DNS platform, it's a different suite of service. For example, we have a private DNS that's serving Azure VMs, and then Azure customers. It's a complete different service. Public authoritative that resolves the internet facing or public domains for Azure, for Microsoft. It's authoritative service. Then we have a recursive resolver where we own the domain, and it's it tries to talk to the authoritative service to try resolve the domains that are hosted on us or hosted on another DNS system. So it's if you and then we are we are in a private preview for a hybrid resolver where customers who are having a custom namespace using the private link and then private endpoint with the Azure offerings, but still want to use their own custom domain. So it's a hybrid DNS resolver. So it's like 4 suites of services. They share some piece of infra because we want to have an efficiency and in the offering, but in its own, they are independent 4 services.
Yeah, so then it's sort of whatever you need, we've got it from a DNS perspective, which is great, right? You want to be able to come to one place. I think the reason I had reached out, because resiliency and uptime is sort of a big thing. It's been a big thing forever, but it's even more critical these days. And you guys recently, have made some significant investments into a decorrelated system. And so, first define that, and then second, what is this, sort of big investment that y'all have done recently?
Sure. So this idea started with DNS as being such a fundamental platform and infra. The SLA of 99.9949 or 49.5 it's still too much painful even for that last 0.00005 to go down. So we discussed with the the leadership and then said DNS has to be the 100% SLA, and to achieve this we have gone through, there are various investment. The one that I would like to call out is we started investing in 2 parallel stack of DNS platform and service. It's built in one on running on the Windows, the other one in Linux. They do not share any code or component. In fact, the deployment and then configuration, the how the data state propagates are 2 different things. And then idea behind this is if you ever happen to get a day 0 bug in the core part of whether it's in the OS or in the way this configuration flows or the way these data is being treated, we would have one system resilient to such kind of failure. So that's the idea towards achieving the 100% SLA that we want to give to our customer. And this is the investment we are making in the past 3 years. And now some of the services are running in active these dual stacks, and especially our recursive resolver and authoritative the public domain DNS services. We want to extend it to all DNS services eventually.
Yeah, and so that's sort of what I was going to ask is the thinking that you talked about some of our services are using it. It does down the road, right? It sounds like at some point customers will be able to leverage this dual stack sort of just as it works. Are they going to have? Is the thinking that customers are going to have to do something different to leverage this, or they're just going to make a DNS query like they always do, and we'll handle making sure that we're running in active and all that? Like they don't have to do anything to get the benefit from this.
Oh, absolutely. Yeah, this is it's completely transparent to our customers. It's 2 stacks that's for the internal systems. We manage the traffic part of failover, active, their configuration replicating simultaneously to both the systems, whatever the change they make. So they are not exposed to underneath having these 2 systems, and it's the thing they do it today. It's exactly the same thing they would be continuing to do for once these 2 systems are in an active state.
Okay. And this was you said this was a 3-year journey. I mean, this was no small feat to to sort of build something that met our requirements and our standards, in this completely new stack. I mean, when y'all started this, I mean, this had to be pretty daunting as far as a path.
It's pretty daunting. I mean, when you build services in Azure, you use some of the basic Azure infra. For example, if you're running a service, you use the cool features the VMSS and all to have give you the compute, the storage to give you storage. But DNS being fundamental, we just couldn't use Azure itself boots on the the DNS.
Right, sort of the circular problem,
it's a
right?
circular,
Yeah.
so we had to cut down it. So when we were having just one stack on Windows, we could not use some of the basic platform, the building blocks of Azure. And then when we moved to the second stack, which is based on Linux, again same thing. We could not use anything that on the basic building block that Azure offers. Also, we could not use whatever the building blocks we had for the Windows world because it has to match this. So it became really daunting, and then we have to also understand the fact it's not one time. This is the two systems that we need to maintain forever, right? The enhancement. So then you start thinking about how do you want to invest in areas where it provides 100% SLA and then the resiliency to our customers, and then ensure DNS is always up. But at the same time, you look into aspects of where you can still consolidate the efforts, which benefits both these stacks. For example, you may want to set up your test infra in outside of DNS and the Windows and the Linux world, and then that's the validation that could do for the both. How you just want to have a parity check, independent system doing, so you don't have to duplicate that effort onto two stacks, dashboards, and then the some of that part also separate out as an independent thing, monitoring both the stacks in the DNS world. So yes, it's one hand pretty daunting, but then we have to really think about how to optimize our engineers and resources to the best.
Yeah, no, this is it's. I mean, as I think about this, this is sort of a running joke. Actually, I'm sure it's a running joke for our customers as well, but it's a running joke here on the podcast. Around the fact that when we started this podcast, many years ago, it was called Windows Azure, right?
Yes.
And that name there's a couple places I could think of that name is still there in an acronym or in an internal tool or whatever, and we talked about how Linux is really and truly part of our DNA these days, and what you're talking about is it's even beyond that. Like, it is literally half of our, I mean, not half is not the right word, but it is an equivalent part of our underlying infrastructure beneath all of this to the Windows stack.
Oh,
right?
absolutely.
I mean, it's 100%. I mean, we're completely bought into this world. It's not just a marketing thing.
Oh, no, it is not. And I know you said we'll take the front door and this it's in its own, but we are adopting Linux as truly a first class citizen in all aspects, and it's not just a thing. It is the thing along with the Windows in Azure world and in many of our services.
So, I mean, DNS, it's one of these services that everyone, people like me take for granted, right? It's there, it just works. And
that's the goal. That's the goal, Russell.
But if you take it away, everything breaks, right? The whole internet goes down. Nothing works pretty much unless you know all the IP addresses that you need to speak to. And I guess even then, some of those aren't going to work. But so how do you go about planning to deploy and test changes when you're making stuff, and how many fingers do you have to cross when you hit the button to put your deployment out there?
Abhishek used to have hair. That's the way it is.
You start using hair once jokes. But yeah, I mean, so the good part is in Azure, all services follow this SDP, safe deployment practices, and then depending upon the services, the SDP notion would vary, but the idea is you would deploy slowly. Like you will create the fault domains of a very lesser blast radius in production. I'm talking about once you are ready to go in production. So in DNS is no different. We have this distributed set of edge pops where DNS infra is deployed, and you start deploying it one by one. And then even if the one or few of the edge sites completely goes down, it does not affect the DNS offering. We have enough the capacity but in other pops to take it over immediately. So that's on the production. But before going to the production, DNS goes through a series of tests. We have a test on to doing the stress and the regression on the performance side. And the reason I'm first touching on the stress and regression side, because we have seen the behavior where we on the DNS side, the system was running absolutely fine, but a change in a system which is not within Microsoft just changed somewhere, and that caused a flood of retries on the DNS and then almost choking our WAN and the services. So we need to make sure our system is really performant and scaled towards these scenarios as well. So it goes through any build changes, it goes through that kind of CPU memory performance query regression suites. With the Linux and Windows world, we also have to ensure it's the functionality is behavior is same for both the worlds. So there is the functional validation across both these stacks, and that ensures the response and results are the same before we even reaching into the production side of the deployment of these services. Then of course we track on the unit test. There is in Azure core, we are up driving a culture towards shift left. Shift left means when you start conceiving that change, it's not you have written a single line of code. You start thinking, how would you validate, do things that would ensure the changes are of quality and you prevent any regression. So that happens. The kind of unit test you would write, the kind of coverage you would do, the kind of monitoring you would once it's in the production. So those are the systems conceived along with the feature itself, and that's how it it helps on the DNS world. And apart from the two stacks, we have different other protection layers, by the way, as well. It's not that just we want to rely, we have two systems, so one can fail, another can easily take over. That's not the case, right? So we try to achieve close to 100% availability on a single stack itself. So there are systems that we have protection, we call it internally Kevlar, that could take all this the different DNS related attacks and serving it from the last known good data right then and there. We are developing the last known good library, which many of the core Azure services like storage, like our Pilotfish Azure Autopilot uses in case the DNS system is not reachable or not performant. It can be still serving through the last known good cache. We also have RFC implemented in our recursive resolver, wherein as part of the recursive resolver service, if the authoritative DNS of the third party not available, we can respond to the client with the last known good data that we got. So these are and other layers we have put into the system, that even if there is a local failure, it's not a outage in DNS, but even if there is a local failure, our client is still not protected against those failures to the extent we can. And those are the systems we do it. We have built over the years in our DNS platform.
Yeah, so you said, oh, sorry, go ahead, Russell.
No, I was just going to say, it sounds like an evolution that's gone through to make it a really mature process now that's really stable, and kind of what we'd expect of the investment that Azure gets. But going back a few years, are there any kind of failures that you've had in production that have been caused by something really minor or something that you're allowed to disclose?
Yeah, I mean, DNS in last few years, at least a year back, had few shares of the outages, and then and this is the investment we started 3 years, and that's we keep on taking these learnings. One data I would like to share, the massive DNS in itself is a global nature from the service owner perspective, but DNS is a global for the customer as well, because they have one domain, right? Like, they bring that domain, and if anything happens to domain, it's a global outage for them. And outages that has happened, majority were related to the migration. When we started this journey, we had a different islands of DNS services, given that how the legacy system evolves. And the idea is like, this is a recipe for more outages and disasters. We want to consolidate, move towards a new platform. Internally, we call it DNS plus platform. And then, like, while doing this migration, this history and context is lost along the way. So we have seen fair share of outages, and that's the part. It's in the culture. We do not take any migration, even if it's like, the simplest, straightforward one, this like easy one. This goes through the scrutiny of, in fact, like, more than the feature that you want to release. So that's one learning. The 2018 outage, the massive outage on the Azure DNS was related to a migration of a old service to a newer service, where one of the common zone was misconfigured on the naming server side of the world. One of the recent, it was not as bad as 2018, but to share, we introduced a log line just to log an extra string in in itself, that it had no bug, but that was taking enough CPU resources that in a storm, like, when some retries and other external event happened, it choked the Europe region in terms of the DNS serving capacity. So that, like, the idea I want to give it, like, this when you run such a critical system, any weak link, you are as strong as in that small weak link. And in that case, that was a log line.
That's amazing. That's exactly
it's the little changes get you, right? The little ones will get you.
And it's that change that, you'd have maybe 50 people could go and review that change, and nobody would spot that it's going to cause a problem.
Yes, right.
Amazing.
You said a couple of things a few minutes ago that I wanted to sort of loop back around on, Abhishek. One thing that I thought was really interesting is that you're investing in the client side of DNS to make sure that the client side is resilient. I hadn't even thought about that as sort of that investment as well. It is, and obviously, it's some of this is potentially down the road, but it sounds like this would show up in like the Windows DNS libraries, or showing the Linux DNS library. So you're contributing things back into that world. So that's where customers are getting other benefit as well.
Yeah, and it's just not the OS library, it's the services would adopt. So for example, like, you were talking about app services. App services could, in their service deployment, use this library and then and control. And then we are consulting with all the critical services to have that, like, the resiliency available in their services for whatever reason, if they cannot reach out to the DNS world.
Okay. The other piece, and we actually, I've talked to some of the AAD folks about this as well. DNS is, I mean, it predates me. I'm sure of, right? It's been around a long time, and it was sort of built for a much simpler world. Right. Are you finding as well that you're having to evolve DNS as a standard itself and as a protocol to deal with the scale and the interconnectedness of the world? Like, are you also having to sort of push DNS into areas that it needs to evolve as well?
Yeah, I mean, like, there, so I'll talk about like three things over there. There are, like, as we know, DNS has evolved like way before us. And then in a way, it's a simple protocol. It, like, you give a name and you're supposed to get an IP address.
It sounds easy, right?
It sounds easy, right? Things are changing, right? Like, from the full domain name, these aliases and things like coming, people want to resolve if they don't type the full, like, www.microsoft.com, just type Microsoft. They expect, or Microsoft.com in itself, they want to have, like, the resolution commit, and the RFC is evolving it to flattening the entire name to get the full name. And it was not supported earlier. That's a small example of, like, how in the newer, easier world, we want to have, like, DNS also play a role to simplify the overall application delivery and experience. The other part is DNS is becoming also a security factor. If you see in the very, like, the DNSSEC, it's not new, but it's like, still not fully adopted. DNSSEC is going in, like, in a way where we can provide the secure way of, like, yes, you are the DNS server that's supposed to resolve, and then giving me the right, not doing, like, the phishing and spoofing and then directing me to somewhere else. And then there is a new, like, proposed standard is DOHT, where it's not just the authentication or authority of the DNS server, which DNSSEC provides, but entire transport of DNS exchange is encrypted, which is over the TLS. So DNS goes over TLS, and that's, like, again evolves, because as a service, like, owner, you have to figure it out. How would you do now this PKI management, certificate management to do that TLS, the extra resources it would take. So it's evolving in that. Then the security vector also, like, the dangling domain, where, like, customer by mistake deletes it, someone takes over that, like, the domain which is available for 5 minutes, and it causes, it's not a attack on the Azure or Azure infra itself, but it's a very painful for the customer who made a genuine innocent mistake, and then someone took an advantage of that mistake. So we have to invest in a system that protects our customers against those genuine and innocent mistakes. So in a way, it's simple, but it's evolving. It's evolving in multi directions.
Yeah, and for anybody that's listening, that we actually had Justin Moorfield on to talk about dangling domains. I think it was right before the end of the year, maybe. But yeah, that's a huge problem for customers, right? Because they don't, I tested something, or I had a production environment before, and I got rid of it, but somebody can sneak in and get it. Yeah, I think that side of some of this is so fascinating to me, right? Because it's not just it's not just us sort of reacting to how customers are using. It's sort of trying to, how do we push the platform, how do we push the capabilities to make it better for everybody, right? Some of the changes that we're contributing to and helping for in DNS, or in a Linux, right? That's going to help somebody else who's running on Linux somewhere else, right? It's not your
domain fronting, domain validation, all these things are becoming a part of the DNS world itself. And then now with the combination of private and then public, right? Private DNS, hybrid DNS. DNS also supports, it's a major building block for the Azure Traffic Manager, which sits Azure DNS infrastructure. So it and that's evolving. In fact, one part I forgot to, like, the mention, DNS as a system also evolving with this complex and then large application, where while responding to the query, it considers, like, your capacity, your traffic rules, which ATM relies on it, right? So it's the entire load management gets into the DNS based system. So yes, it's a simple thing, but it's
what that means is, give it another year or two, we'll have you back, and you can tell us about the the cool things that you've had to do since between now and then. No, this is great, Abhishek. Any last comments you want to leave the audience with?
Yeah, I mean, like, I just want to say is, like, on the DNS side of the world, this is a journey. And then we started with some of the deep down work or dual stack, and then the resiliency and aspect. But I do expect DNS evolving in a way where it would protect and then serve our customers in another ways. It's like, whether it's a security, whether it's, like, the application experience, or the management of the traffic and load onto the back end of their application. So it's an integral part of system.
That's I think the last one, sort of, now my brain's spinning of, like, wow, DNS is going to help me manage load on my app. Like, that's, like, I know that's a thing because I know traffic manager thing, but, like, I had never thought about, wow, that's a part of the puzzle, right? Of keeping my application up and going. Yeah, no, that's neat. Well, great.
More to it, isn't there? I think I'm looking forward to hearing from you about Front Door as well, because I think CDN caching is quite a simple thing, but
don't give it away. Don't give it away. It's like a cliffhanger. Come back next week. No. Yeah, no, this is great. Thank you, Abhishek. We'll definitely look forward to having you back on, talk about Front Door, and then on a future date, coming back on about DNS again.
Yeah, thank you. I would love the opportunity, and thank you for providing the opportunity to talk about the DNS system.
it's it probably the audience probably gets tired of hearing it, but the joke, but it's so nice, Abhishek, to be talking to you in a case where one of us is not getting yelled at, right?
Yeah.
It's a happy conversation.
Right.
Okay,
Yeah.
great. Thanks, everybody.
Thank you.